Okay, we shall discuss next chapter, that is Introduction to Euclid's Geometry. Okay, the word geometry comes from the Greek words geo, meaning the earth, and the metrine, meaning to measure. Okay, so geometry is nothing but study of or measuring the earth, so measurements. So Euclid's and many mathematicians study that. So Euclid gave many definitions for this geometry, this chapter, so that we will discuss. Okay, here you can see that Euclid, who lived 325 BC. Okay, so Euclid's definitions and axioms and postulates. Okay, Euclid gave some definitions, so that is about point, line, and the ends of a line are points. So different definitions he has given. Please write in your notes these definitions. Okay, the first point is a point is that which has no part. Okay, so it is just a point which has no part. Suppose if you consider a circle, then you can divide into many parts, but a point is nothing but just a dot. Okay, so which has no part. You cannot divide a point, half point, you cannot tell like that. So similarly, second, a line is breadth plus length, so it is endless, so we cannot measure like that if it has no ends. Okay, sometimes it has end. If it has end, the ends of a line are points. Okay, so a straight line is a line which lies evenly with the points on itself. So then a surface is that which has length and breadth only. The surface like a book. Okay, it has length and breadth. The edges of a surface are lines, so edges you can see straight lines. A plane surface is a surface which lies evenly with the straight line on itself. Okay, now let us see. So what do you mean by postulate and axioms? So you can see here axioms and postulates. He used the term postulate for the assumptions that were specific to geometry. So the assumptions which were made, which were specific to geometry, okay, only geometry, are called postulates. And common notions, that is called axioms, that were the assumptions used throughout the mathematics and not specifically linked to geometry. Okay, axioms means the assumptions used throughout mathematics. Okay, but postulates are assumptions, so means we think it is correct. So that is the meaning of assumptions. So assumptions related to geometry. Okay, so some of the axioms are given here. Euclid's axioms. First one you can see here: things which are equal to the same things are equal to one another. Okay, so if equals are added to equals, the wholes are equal. Similarly, there are 7 points are given, 7 axioms. You can go through that. And also you can write these 7 Euclid's axioms in your notes. Okay, some postulates are also given. Euclid's 5 postulates. First one, postulate 1: a straight line may be drawn from any one point to any other point. So if you want to draw a straight line, then you have to start from a point and end to another point. Okay, so that is the meaning of postulate 1. A straight line may be drawn from any one point. From one point you have to start, and that has to and to any other point, so another point somewhere, so it may be, so any 2 points you can join with a straight line. That is the meaning. And axiom 2.1 is given 2 distinct points, there is a unique line that passes through them. If 2 points are given, then you can draw only one line. That is the meaning of unique line. Only one line you can draw. So similarly, postulate 2: a terminated line can be produced indefinitely. If the line is terminated like this, then it can be produced indefinitely. It can be moved. Okay, so indefinitely means no end, so in both directions. So that is about postulate 2. Then postulate 3: a circle can be drawn with any center and any radius. A circle can be drawn with any center and any radius. Any point you can consider. You can consider center here, you can consider center here, and particular radius you can draw a circle. Postulate 4: all right angles are equal to one another. All right angles. So right angles means 90 degree. So all right angles are equal to one another. So if a straight line, next one for straight, if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. Okay, that is postulate 5. If a straight line falling on two straight lines makes the interior angle, so let me explain this with the paper. So what does postulate 5 say is, if you consider any two lines, then if any one line falls here, then sum of these two angles, the sum of these two angles is less than 180 if you add these two angles. For example, this may be 60 degree, this may be 75 degree. So when you add these two angles, if the sum is less than 180, then when you extend these two lines, they are going to meet somewhere when it is less than 180. If it is not less than 180, if you consider here, so definitely it is more than 180. So if you extend this, produce, they are not going to meet anywhere. Okay, so that is postulate 5. So there is one more theorem, theorem 2.1. What does it say is, two distinct lines cannot have more than one point in common. So if you consider any two lines, then it cannot have more than one point in common. Okay, so if you consider two lines, okay, like this, and if you extend them, they are going to meet at only one point. Okay, so suppose if they are parallel lines, so there will be no point in common. So that is the meaning of theorem 3. So exercise 2.1. So which of the following statement are true and which are false? Give reasons for your answers. Okay, you have to tell true or false. First one, only one line can pass through a single point. So only one line can pass through a single point. If you consider a point here, then definitely I can draw as many lines as I like, correct? So therefore the first statement is false. Second, there are an infinite number of lines which pass through two distinct points. When you consider two distinct points, you can draw only one line. What does this say? There are an infinite number of lines, means as many lines as you like. So but which is not true, right? Only one line you can draw, so therefore it is also false. Then a terminated line can be produced indefinitely on both sides. So that is one of the postulate actually. So if this is the line, terminated line, then definitely I can produce on both directions. So therefore the third one is true. Fourth one, if two circles are equal, then their radii are equal. If two circles are equal, then their radii are equal. So it is also true. If two circles are equal, then radii must be equal. True. Okay, in the exercise 2.1, so we have to check whether it is true or false. In the fifth one, so in this figure 2.9, AB is equal to PQ. AB and PQ are same, equal in length. Okay, if it is 1 meter, it is also 1 meter. And PQ and XY are equal. These two are equal. Then AB is equal to XY. We have to check whether this is true or false. Now AB is equal to PQ is given, correct? AB is equal to PQ given, and we know that PQ is equal to XY. So therefore in place of PQ I can write XY. So therefore AB is equal to XY. So therefore it is true. So the statement is true. Okay, in the second main, in the definitions, parallel lines, we have to define parallel lines. What do you mean by parallel lines? So when you consider two lines, they are said to be parallel if they do not intersect when they extend indefinitely, like railway tracks. Okay, they do not intersect. So that is the meaning of parallel lines. Two lines are said to be parallel if they do not intersect when they are produced indefinitely. Okay, so they will be having same distance. Next one, perpendicular lines. Two lines are said to be perpendicular if the angle is 90 degree at the point of intersection. So that is, if the angle between two lines is 90 degree, like that also you can define. So like this, angle is 90 degree. So next, line segment. So line segment is nothing but a part of a line. Okay, if you consider any part with two endpoints, so that is called line segment. Next, radius of a circle. So radius, if you consider circle, then it has a center and a perimeter. So this is called perimeter or circumference. So distance of this point from the circumference, if you calculate any distance, all distance will be same. Okay, so this distance is called radius. Distance of a center of a circle from its circumference, okay, denoted by r. OA is equal to r. Next, square. It is a quadrilateral with all sides equal and all angles equal to 90 degree. So it is a quadrilateral. Quadrilateral means a shape which has four sides. Okay, so it has four sides, so it is called quadrilateral with all sides equal and all angles equal to 90 degree. So that is called square. Next problem. If a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to half of AB. So if a point C lies between 2 points A and B, so if I consider 2 points A and B, C lies in between A and B. C is somewhere here such that AC is equal to BC. So if this is 5 meter, then BC is also 5 meter. AC is equal to BC. Then we have to prove AC is equal to half of AB. So now here you can see that AB is equal to, so AB is equal to, or you can write AC plus BC is equal to AC plus BC is equal to AB, right? If this is 5 meter, then total will be 10. So AC plus BC is equal to AB. Now AC plus BC is same as AC, so I can write AC in place of BC because both are same, is equal to AB. AC plus AC, 2 times AC is equal to AB. So therefore AC is equal to 2 into, so multiplication becomes division. So I take this 2 to the right hand side, so AB. So that is the required answer. AC is equal to half of AB. Next one, in the figure, if AC is equal to BD, AC is equal to BD, then prove that AB is equal to CD. AB is equal to CD we have to prove. So given that AC is equal to BD, AC is equal to BD, there it has been given. Okay, so now AC, so I will subtract this BC, minus BC is equal to BD minus BC. So subtracting both sides by the same term. Okay, will not change the equation. So AC minus BC, BD minus BC. AC minus BC, AC minus BC is equal to AB. Okay, in the AC, in the part AC, if I remove BC, then remaining will be AB. So in the same way, in the part BD, if I remove BC, then remaining will be CD. So AB is equal to CD. That is the required answer. Okay, next concept is equivalent version of Euclid's fifth postulate. So that is, we know that in the fifth postulate it says that if you consider any two lines, so it is in the previous page here, if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angle is less than two right angles. Okay, so the equivalent version is given here. So that is, for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. Okay, there are many equivalent versions, so this is one of them. Okay, you can see here, if you consider a line and a point somewhere not on the line here, then we can draw many lines passing through this point, but we can draw only one line passing through this which is parallel to this line L. Okay, so that is the meaning of the equivalent part of Euclid's fifth postulate. It is also stated like this: two distinct intersecting lines cannot be parallel to the same line. If you consider two intersecting lines, both these lines cannot be parallel to the same line. Okay, so if you consider this line, then you have to draw like this or like this, okay, which is not parallel to another line. So that is the meaning of this statement.